Okay, for the automation of the process, first we need to see the directory. So we are in Scratch, user and file called automatic. So in this file you need to follow this structure for the codes to work. The code by itself and then the different configuration, because in this case we are not changing, for example, the velocity of the physical parameters. That is more simply because you only need to change the constant and the system file. We are changing the length and the height of train, so we are changing the CAD model, and to do that we need different directories with different CAD models with different things. So that's because we are using this kind of distribution for the physical parameters. Saying that, we are going to see the structure of one of these to follow for the code to work, and this is typical for the OpenFOAM system form constant 0, and 0 origin, that is like a security copy for 0. Then we are going to see a little bit the codes. So first this one that change the mesh automatically, so in only one case, that one, and use this kind of approximation BDM, which means block mesh disk, that is 0.8. so basically make the block mesh disk 20% more thicker, or 20% in this case more thinner, because the original block mesh is here, that is 250 4040. And then we have, for example, this one that's level 5, because the maximum level of refinement in the train in the snappy mesh is 4, as we can see. For example, here is the original one, the maximum refinement is 4 and the height is 002. So this one change the refinement up to 5 and change also the height. And then we have something like this that mix both effects. So then to launch the things, you only need to put Python 3 and the code name and launch everything. We also can see it there in the queue stat, like that. Then they are like that, and it generates all these kind of files. We are going to see this one because I think this one is actually running. That one. So if we put it, yeah, it's still running, and it's generate the structure, the logs, and the run file that run all in this case. And if we can go to system, we can see the block mesh. We can see the block mesh, and as we can see, it's 20% smaller. It's 200 instead of 250. And if we see the snappy, it's up to level 5 here in the train, and with a height of 004, as is specified here in the name of this run. So it's working well. Then for the other code, this one just run the different physical parameters as the different simulations of height and length, and it's also, with only one case, change the amount of CPUs required. So also to run is just as simple as put Python 3 and the name of the code, and it's launch everything to the queue stat, so we can see it here. It's everything in the queue, and the most important thing is that for example, the one that needs 4 CPUs is asking for 4 CPUs. The one that needs 10 CPUs is asking for 10 CPUs. So it's everything as it needs to be.